First of all, I will give a brief introduction on Hangzhou and the First Stack. First Stack actually is founded in Hangzhou, which is a very beautiful city and very creative. Hangzhou located very near to Shanghai. It's around 200 kilometers away. And there is a big lake and a big river in this city. So you are very warmly welcome to visit Hangzhou in the near future. And about First Stack, First Stack was founded in 2011 by three very talented engineers. So we're focusing on power electronic solutions for almost 40 years now. So from the very beginning, we just have three co-founders, and then now we have 400 employees already, and among half of them is engineers. So it's a big team now. So we have our own R&D centers and also customer centers. And this year we will also open up our manufacturer centers. So it's a lot of increase. And for us, we have already delivered for more than 4 million pieces of gate drivers. And we also supported for more than 115 gigawatts power generations products. And then the second part, I will give an introduction on what we do, what we are doing, and what we will do in the future. So First Stack's product, from the very beginning, we focus on the gate drivers. So our products covers from 650 volts, from 650 volts to 6,500 volts products. And also we not only cover the single devices solutions, also our products can handling the parallel solutions of high power IGBTs. And also from 2020s, we have our own control chip. It's called ASIC. So we have our own ASIC, which is digitalized the solutions for gate drivers. And the second part is the test equipment. From 2018, our department of test equipment set up. So we provided from the laboratory testing equipment, also for the foundry testing equipment. And also our products covers from the reliability evaluations from the wafer level to device level. And our customers and application area and field. So our gate drivers can support it from the power generations, power transmissions, from power distributions, and also consumptions. So from this point of view, our products goes to almost everywhere for the electrical generations. And just as mentioned just now, we have supported 150 gigawatts power generations. Our products have supported such a large amount of power generations now. And for the test equipments, more than 100 partners and customers globally, which located into the real tractions and also the IDM and the foundries, and also the EV makers, and also some university and R&D centers. So from this slides, you can see we have a very broad customers globally. And then I will give the introductions on the First Stack's solutions on silicon carbide devices. So now, as we know, recent days, because of the developing of AI technology and also the EV technologies, it has pushing a very large demand of energy consumptions. And it is predicted that by 2040s, so AI and EV will count for 24% of the total electricity consumptions. So it's a very large energy consumptions. And this will pushing a very surging demands of silicon carbide devices because of we need a very high frequency, very high reliable and high frequency power transmission, power generation, and power consumptions. So silicon carbide is very promising materials in this point of view, but there are very large challenges because of the issues of silicon carbide materials. There are a lot of compared to the silicon-based devices, silicon carbide-based devices will have a lot of defect issues. And take the HBD module as an example. So normally, HBD power module may have 84 dies, made up by 84 dies. So assuming that if the defect rate from a wafer is just 2%, so when it made up HPD devices, it means that this guy, the failure rate will be 100% failure. So from this point of view, selecting and also testing about the material, the silicon carbide-based devices is very, very important, and it is very critical. And from this point of view, so the earlier we can select the devices, the better. So for example, if we do not do the testings and the screenings from the wafer level, from the die level, we will have to do the testings and the selections from the device level. It will cost a lot of time and money because the failure rate of such devices is quite high. So from this point of view, for silicon-based devices, it is proper and it is possible that we just testing devices at the final test process. But for the silicon carbide-based devices, it is not possible. So we need to do the testings and the screenings at the very early stage of the process. So it is better to make it from the wafer level, and then from the die level, and finally from the device level and application levels. And then what's the first type we provided? We provided total solutions for silicon carbide devices, testing solutions, and also screening solutions. So we provided wafer level testings, and the die level testings, and the device level testings, and also application level testings. First, on the wafer level testings, we provided a solution. It's called wafer level test. It's also called wafer level burn-in. So this equipment can burn in the 6 and 8 inch silicon carbide wafers, and it will support it 2 kilowatts voltage, and also its function can be HTRB and HTGB, and also we can go to the threshold voltage and also the leakage current informations. And to be mentioned that this burn-in process is very critical and a must process for ensure that a very high quality of silicon carbide devices. And also we can support it 200 degrees high temperature testings for even 2 hours. And some manufacturers even do a 1,000 hour testings for their wafers. And then after the wafer, when the devices has been cutted, it's called testing the chip. It's called the KGD, the no good die. So for silicon carbide dies, it is very important to testing the static and the dynamic characteristics, and also the avalanche testings. And what we provided is that we provided a very ultra-fast protections. And this is a very critical process because once you are testing a silicon carbide die, you will see experience if your protection time is longer than 1 microseconds. So the protecting devices and the protecting procedure is quite important. So we can provide it a very fast protections. And then when the die is combined into a device, we also provided solutions for the die level testings, which called auto test equipment, and it is also called the final test for devices. We provided static testings and also dynamic testings and the double pulse and the short circuit testings. So for this kind of testings, also the protection is quite important and critical. But for the device, it is much easier because we can use a 1 microseconds protection. Is compared to the die, it's much easier. And also we provided a very high UPH. This is an example we have provided for our customers for IDM and foundries. So you can see from this figure, so we provided insulation testings and high temperature static testings, and also there's cooling stations. And you can, after the cooling, you can do another static and dynamic testings. So this is an example we have provided to our customers. This is a testing equipment with automatic handlers. And with this system, we can install 100 or 700 UPH testings, which means you can testing 300 devices in 1 hour. So you can test 10,000 in a month. So it's quite a large amount of testings. And then we also provided the laboratory level testings, which mainly focus on the power double pulse testings. And for the electrical EV applications, we also provided the -50 testings. So this is quite important because the EV will be operated in a very low temperature. So this is for the EV application. This function is quite critical and important. And then another one is we call now is very popular, and the manufacturing are doing their research on the reliability evaluations of silicon carbide devices. This is standard is called AQG 324. So based on from this two catalog, you can see that for silicon-based devices, you can just do the static testings. It's enough. But for the silicon carbide devices, you can see there are more items, more catalogs to be tested, which means that you need to do a lot of dynamic testings. We need to give very high DVDTs to silicon carbide-based devices to accelerate the defect rate to find if there's a problem or issues on the reliability of silicon carbide devices. And this is the details in this standard. For example, for the DDS, we need to give a 1 volt per nanoseconds, a very high DVDTs, and a high frequencies. For the DRB, we also need to give a very high DVDTs, which is 50 volts per nanoseconds. And based on this standard, and we develop our own product. This product, this equipment can provide 2 kilowatts voltage, and also up to 1 volt per nanoseconds DVDTs to the gate signals, and also the RB. To the drain signals, we can give a 50 volts per nanoseconds DVDTs, and also this equipment can supply the very high temperature test equipment atmosphere from the room temperature to even to 200 degree temperatures, and also for different packagings of devices. So we can give different frequencies, and for the GB, we can give up to 500 kilohertz frequencies. For the RB, we can give 50 kilohertz frequencies. But these parameters depend on the packagings of the devices, because bigger packagings will have a large strain inductance, and also it will generate a lot of heat. So it also depends on the different packagings of the devices. So that's all.